Pretty, isn't it? Some people call this a crystal garden. I'm afraid, though, it doesn't really happen that fast. We had to speed up the film. But they are easy to grow. What you need is some of this stuff, which is called water glass. Get that from the chemist. And you need some ordinary tap water. 7 times as much water as water glass. Then just mix them together, like so. And just drop in a suitable substance, like this one, which is called cobaltous chloride. Sounds good, doesn't it? Pop that in there where you can see it. A bit more. And something else, a bit of colour over here, nickel sulfate. Gaudy colour, isn't it? And now, all you need to do is wait. Tell you what, why don't we speed up the film again? But why is it called a crystal garden? Well, take a look at this substance here, nickel sulfate. Now, if you have a really close look, preferably through a magnifying glass, you can see it's really just a collection of tiny crystals. And when you put those crystals into the water glass, they grow. You see crystals in a surprising number of places. You probably tread on crystals every time you cross the road. It's crystals that give the speckled appearance in curbstones like this. These are crystals of the mineral feldspar. And there are crystals in the rock that's been used to face this bank. Like the curbstones, the rock is granite. This particular granite is pink. And just occasionally you'll find street furniture made from granite. You can always spot it from its speckled appearance. This is due to a mixture of crystals of different minerals in the rock. You get a better idea of the crystals in this piece of granite. See how they all have flat faces and sharp edges? That's an important property of a crystal. You might think this is rock. Well, it's not. It's a lump of metal called bronze. Now, this is where it's been snapped in half, and what do you find? Surprise, surprise, crystals. And they too have got flat faces and sharp edges. So metals are crystalline too, not just bronze. Here's a piece of a metal called zinc. Now, look at the edge there. See? Crystals, where it's snapped off. Take an even closer look under an electron microscope and you can see the flat faces and sharp edges. Under this magnification, it's almost possible to make out the shape of the crystal. So that's zinc. And here is tin, almost as pure as you can get it. Now, there's some smashing crystals on here. Look at that one there. Very definite shape. It's got square sides, 4 sides, and on the top, a 4-sided pyramid. What about this? Salt. It's got crystals as well. There we are. Oh, they're even smaller. And under the hand lens, see 1 or 2 of them there. Oh yes, there we are, there. Flat sides, sharp edges. But if you want to study its shape, you need to look more closely, again under an electron microscope. They're cube-shaped. Sugar. Going everywhere. There we are. Easier to see. Now then, oh yes. Yes, they're a good shape, but are they the same shape as the salt crystals? Take an even closer look, you say. Well, that's not the only way. Look at this. A whole cluster of larger sugar crystals. Much easier to make out their shape. Now, you can grow crystals a bit like this, but unfortunately sugar isn't the easiest stuff to do it with. This is a much better bet. It's called alum. Actually, it's called aluminium ammonium sulfate, but people call it alum. I can't blame them. There we are. Thousands of tiny crystals. But you can make them grow into something like this. And then you can really see the shape. Ah yes, but how do you grow something like that into something like this? Well, let's ask the experts. Right, how do you start growing these crystals then?
You dissolve the alum in water
I see. How much alum do you need?
as much as you can
Right, so you've really got to dissolve as much as you can in there. How do you do that?
by stirring it.
Mm-hmm. Anything else?
When you heat it up,
But not too much, just enough to help it dissolve. Fine, but what do you do when you have dissolved as much as you can?
When I can't dissolve anymore, I leave it to cool.
Okie doke. Now I think somebody down here's done that. Is that cool now?
Yeah, it's cool.
Right. What's happened?
You can see the crystals forming at the bottom.
How long did that take?
About an hour.
I see. Well, the really interesting thing is to see that happening. So let's speed up the film again. You see how the crystals form? But that's about as large as they grow. Fascinating, that, isn't it? Now what do you do?
I have to pour the liquid in here.
Right.
And I split the crystals out.
Right, scrape them onto a filter paper.
Yeah.
Uh-huh. What do you do? You're looking for the best one, are you?
Yeah, I'm going to look for the best one.
So when you've got one, what then?
I have to stick it on some thread and let it dangle in this liquid.
Stick it onto a thread and then dangle it back in the liquid. Well, that's a bit tricky. So, here, as they say, is one we did earlier. Well, there's our crystal dangling on a thread and suspended in that solution. And now you need plenty of patience and lots of time, maybe a month. So let's speed up the action. Now look at this. What a beauty. Now that's what you call a crystal. You see? Got a very definite shape, just what we expected. Rather like two pyramids stuck together. Right, well, that's fine. Remember, that's called alum. But here are some crystals grown from a solution of copper sulfate. Now, it's not just one crystal. It's a whole cluster of smaller ones. And here's another cluster of crystals. These are grown from potassium dichromate solution. And once again, the shape is different from the other ones we've seen. So we're surrounded, it seems, by lots of different crystals, but they all have certain things in common. For example, those flat faces and the sharp edges. But what other similarities are there? And what differences are there between crystals of one substance and crystals of another? And something else too, where do you find crystals? Well, lots of good places to try. You could try in a kitchen, or out in the street, a science laboratory, of course. What about a museum, or even out in the countryside? Oh, and you could try growing your own crystals, in which case you can sort them out into different groups according to perhaps the colour, or the shape, or how valuable they are, or where you might find them. But you know, if you do want to observe crystals growing, you don't need to wait forever, and you don't need special photography. You could watch them growing under a microscope. Have a look at this.